Hello dear students, in this video we are going to discuss about one of the important and core subject of electrical engineering. The subject is electrical circuits. This subject is for third semester of electrical engineering. It is having a subject code of 22324. First, we will see a marking scheme for this subject. This subject is having total weightage of 150 marks for third year out of 800 marks. This 150 marks are divided as the subject is having theory paper of 70 marks, then 30 marks for class test 1, class test 2 and mini project. All are having 10 marks each. Then the subject is having external oral examination, that is for 25 marks, and 25 marks are for internal term work. This way it is having total weightage of 150 marks. The subject is having total 5 chapters for this semester. In that, first chapter is single phase AC series circuits. This chapter is having a weightage of 15 marks. Second chapter is single phase AC parallel circuits. This chapter is having a weightage of 13 marks. Third chapter is three phase circuits. It is having a weightage of 13 marks. Fourth chapter is network reduction and principles of circuit analysis. It is having a weightage of 13 marks. And the last chapter is network theorems. This chapter is having a weightage of 16 marks. So in this subject you are going to study total 5 chapters for 70 marks. Now we will start a first chapter, that is single phase AC series circuit, which is having a weightage of 15 marks in theory examination. In this chapter, the first point is generation of alternating voltage. In this point, we are going to discuss how an alternating voltage gets produced in the machine. Now, the machine which produces an alternating voltage called as an alternator. This alternator works on the principle, and the principle is when flux cut by the conductor and EMF is induced in the conductor. I repeat, when flux cut by the conductor and EMF is induced in the conductor. म्हणजेच जेव्हा एखादा कंडक्टर फ्लक्स कट करतो त्यावेळेस त्या कंडक्टरमध्ये EMF म्हणजेच व्होल्टेज तयार होतं. It is a working principle of an alternator. Now we will see a construction of an alternator. To produce an alternating voltage, we need two important quantities, that is, first is flux and second is conductor. Now for production of flux we required two permanent magnets. On the screen you are watching that we are having two magnets, that is N pole and S pole, and between the magnets some dotted lines are shown. That dotted lines represents the flux, that is a magnetic field. Now we required a conductor. Now a conductor, it is made up of either copper or aluminum or any conducting material which is placed in this magnetic field. Here the conductor, that is a coil of conducting material, is placed in the flux, that is a magnetic field. The construction of overall structure is like, it is having two permanent magnets, that is N pole and S pole, which produces a flux. In the flux we have placed one coil that is made up of conducting material. A shaft which is connected to this coil having two springs C1 and C2 and two brushes made up of carbon are connected to these springs, from which we are going to collect a current. Now we will see how it works. Again we will go back to the principle. When flux cut by the conductor, an EMF is induced in the conductor. When we rotate this coil in the magnetic field, that time this coil cuts the flux, so that as this coil cuts the flux, an EMF is induced in this coil by the principle, and due to this EMF a current starts to flow through the coil. That current is collected through the brushes, and this current will flow through the resistor shown in the diagram. Likewise, as coil rotates in the magnetic field, it cuts a flux and a current is induced, that is an EMF is induced in the coil. Now we will see a waveform of voltage or a waveform of EMF that is induced in the coil. The first condition is when this coil is in parallel with the flux, that is it is having an angle 0 degree with the flux, that time no flux will be cut, so that there is no generation of EMF in the coil. So in the graph we are put the magnitude of voltage at 0 degree, that is 0. Now as coil gets rotated, it starts to cut the flux, and when coil is at an angle of 90 degree, that is totally perpendicular to the flux, that time it cuts the maximum flux and a maximum amount of EMF gets induced in the coil, that is at a 90 degree. So in the waveform we can see at 90 degree the voltage induced in the coil is maximum. Now again when we rotate this coil, then the amount of flux cut gets reduced, and when this coil is at an angle with 180 degree, then no amount of flux cut by this coil, so no amount of EMF gets induced in the coil. That is, at 180 degree the magnitude of voltage induced in the coil is 0. Likewise, when we go for 270 degree, the maximum amount of flux will cut by the conductor, and the maximum voltage gets induced in the conductor. And at 360 degree, no flux will cut by the conductor and no voltage will produced in the conductor. Now this is a graphical representation of voltage induced in the conductor, and that graphical representation is called as a waveform. विद्यार्थ्यांना या पॉइंट संदर्भात काही शंका असतील तर त्यांनी कमेंट्समध्ये लिहून पाठवायचे आहेत. Now there are some definitions which are required and related to this AC quantities. In that, first is waveform. The waveform is nothing but a graphical representation of an alternating quantity. In the graph you are watching that on x-axis we have taken a time, and on y-axis we have taken a magnitude of voltage, and the magnitude of voltage we have taken with respect to time. Now whatever structure is shown on the screen, that is a waveform of voltage. Again we define a waveform is a graphical representation of alternating quantity. Now second important quantity is cycle. Now in the waveform, the portion from 0 degree to 180 degree, that portion is called as positive half cycle, and the portion from 180 degree to 360 degree is called as negative half cycle. Now the cycle can be defined as it is a total portion in the waveform from 0 degree to 360 degree. That is, cycle consists of one positive half cycle and one negative half cycle. Likewise, cycle in another language we can define that cycle, it is that portion in the waveform which consists of one positive half cycle and one negative half cycle. Now the third important definition is time period. Now in the graph at down we can see time period which is mentioned by capital letter T. Now time period we can define as it is a time taken by the waveform to complete a one cycle. म्हणजेच एक पॉझिटिव्ह हाफ सायकल आणि एक निगेटिव्ह हाफ सायकल दोन्ही मिळून जी एक सायकल तयार होते ती एक सायकल पूर्ण करण्यासाठी त्या वेवफॉर्मने घेतलेला वेळ म्हणजेच टाइम पिरियड, and it is always denoted by capital letter T. Now we can calculate this time period by formula T is equal to 1 upon F, and it is measured in second, where F is a frequency of the quantity. Now fourth important parameter of alternating quantity is a frequency. Now frequency we can define as the number of cycles completed by an alternating quantity in 1 second. म्हणजे एका सेकंदामध्ये त्या वेव्हफॉर्मने किती सायकल्स कंप्लीट केल्या, नंबर ऑफ सायकल्स completed by an alternating quantity in 1 second, that is called as an frequency. And in India we are using a standard frequency of 50 Hertz, where Hertz is a unit of frequency. There is one formula for frequency is F is equal to 1 upon T. It is measured in Hertz. Now the next parameter is peak value or maximum value. Now peak or maximum value can be defined as the value of alternating quantity at 90 degree in the waveform, called as a peak or maximum value. In the waveform we can see one dotted point at above the 90 degree, that is the peak value of voltage. The peak or maximum value is always denoted by letter Vm or Im. Now we will discuss about the circuit elements. It is one of the important point from this subject or of an electrical engineering. So be careful while studying this point. First element is resistor. The resistor, it is an electronic device which is used in the circuit to control the value of current. It is always denoted by letter capital R. The symbol for resistor is shown on the screen. The value of resistor is called as resistance, that is at what amount this resistor is going to oppose the flow of current, called as a resistance. It is measured in ohm, and the symbol we use for ohm is shown on the screen. Now the value of resistance, when we calculate resistance for a given material, then we use the formula R is equal to rho L upon A, where rho is resistivity of that material, L is the length of that material, and A is a cross sectional area of that material. The resistance is one of the important, very much important element of electrical circuits. Now second important element is an inductor. An inductor is always represented by capital letter L. The inductor, it is also an electronic device used in an electrical circuit. The function of an inductor is to oppose the change in current, and at what percentage or at what amount it opposes to change in current, that value is called as an inductance. Inductance means it is opposition provided by an inductor to change in current. The symbol we used for an inductor is shown on the screen. We use Henry as a unit for an inductor. It is always denoted by capital letter H. The formula by which we calculate the value of an inductor, that is L is equal to N pi upon I, where N is number of turns of coil, phi is amount of flux, and I is amount of current through this coil. That is, inductor is also one of the most important element of electrical circuits. Now we will go for third important element of electrical circuit, that is nothing but a capacitor. Capacitor is always denoted or represented by capital letter C. The symbol we use for the capacitor is shown on the screen. The unit we use for the capacitor or to calculate the value of capacitance is farad, and it is always denoted by capital letter F. Now the capacitance can be calculated by using formula Q upon phi, where Q is a charge on the plate and phi is a supply voltage of the circuit. That is, capacitor, it is also an electronic device, and the function of capacitor to oppose the change in voltage, and at what amount it opposes to change in voltage is called as a capacitance. That is, a resistor, inductor and capacitor are most important elements of electrical circuit or electrical engineering. त्यामुळे ह्या स्क्रीनवरती जे काही एलिमेंट्स दिसत आहेत, त्यांचे जे काही सिम्बॉल्स आहेत, युनिट्स आहेत आणि ते कॅल्क्युलेट करण्यासाठी वापरले जाणारे फॉर्म्युला आहेत, हे अत्यंत प्रामाणिकपणे लक्षात ठेवणं गरजेचं आहे. हे जोपर्यंत आपण आहोत तोपर्यंत आपण यांना सोडायचं नाही आहे आणि हे आपल्याला सोडणार नाही आहेत. त्यामुळे हे आर, एल आणि सी हे पूर्णपणे लक्षात राहील या दृष्टीने याचं प्रिपरेशन करा. नाउ वी विल गो फॉर नेक्स्ट कंटेंट्स. There are some important terms about an electrical circuit. In that, first is RMS value. Now RMS value means it is a root mean square value of a AC quantity. I repeat, RMS value is a root mean square value of an AC quantity. When this quantity is in the form of voltage, then we calculate phi RMS is equal to Vm upon root 2, where Vm is the maximum value of voltage. In the waveform we have seen that maximum value which occurred at a 90 degree, and when this quantity is in the form of current, that time we calculate IRMS by using formula IRMS is equal to Im upon root 2. Now we will go for next important quantity that is average value. Now average value can be defined as it is the average of all the instantaneous values of an AC quantity. When the quantity is in the form of voltage, that time we calculate V average as V average is equal to 2 Vm upon pi, and when the quantity is in the form of current, that time we calculate I average is equal to 2 Im upon pi. Again I repeat, average value is the average of all the instantaneous values of an AC quantity. It may be in the form of current or voltage. Now we will go for next quantity, that is impedance. इलेक्ट्रिकल इंजिनिअरिंगमध्ये अतिशय महत्त्वाचा आणि प्रत्येक न्यूमेरिकल सोडवण्यासाठी लागणारा पॅरामीटर, that is called as impedance. It is always represented or denoted by capital letter Z. To understand an impedance, we have to go through a simple series RLC circuit where R is a resistance offered by resistor, XL it is a opposition offered by inductor, and XC it is opposition offered by a capacitor. Now we calculate Z by using formula as Z is equal to R plus minus jx, where R is a resistance or opposition offered by resistor and X is a reactance. Now reactance, that X is calculated as either XL minus XC or XC minus XL. Now depending on the magnitude of XL and XC, that X means reactance can be calculated. Now when to use XL minus XC and when to use XC minus XL, that is when the value of XL is greater than XC, that time we have to use XL minus XC, and when the value of XC is greater than XL, that time we have to use XC minus XL. This way we calculate the value of impedance Z is equal to R plus minus jx. Now we will see inductive reactance, that is XL. Now what is meant by inductive reactance? Now the inductive reactance can be defined as it is an opposition offered by an inductor. It is always denoted by XL and calculated using formula XL is equal to 2 pi FL, and this reactance is measured in ohm. Same way capacitive reactance is there. It is also defined as it is an opposition offered by a capacitor. It is always denoted by capital letter XC and calculated using formula XC is equal to 1 upon 2 pi FC, where F is a frequency of supply and C is a value of capacitor. The unit for reactance or inductive reactance is ohm. Both inductive reactance and capacitive reactance and impedance are measured in ohm. Now we will see one more important definition related to phasor, that is phase angle. Now phase angle is always denoted by the symbol phi. Now we are having one small diagram. One phasor represents voltage and second phasor represents the current, and between the voltage and current we are having one angle, that is phi, and that angle is called as a phase angle. Now phase angle is always defined as it is angle between voltage and current, and it is represented by a symbol or a letter phi. Now we will see a leading quantity and lagging quantity. So in simple words or in simple language, we can define leading quantity and lagging quantity as when the value of phase angle is positive, then the quantity is leading quantity, or we can say that this quantity leads other quantity, and when the value of phase angle is negative, that time this quantity is lagging to another quantity. Now from this phasor diagram, leading quantity, about leading quantity we can say that the phase angle is positive, that is current I leads the voltage phi at an angle phi, and about lagging quantity we can say that current I lags the voltage phi at an angle phi. So depending on the values of phi, either it is positive or it is negative, we can define that it is leading or lagging. So in the phasor diagram, while drawing the phasor of an electrical circuit, it is very much important to understand a phase angle and leading quantity and lagging quantity. तर या संपूर्ण व्हिडिओमध्ये जे काही कंटेंट्स सांगितले गेलेले आहेत ते सगळे कंटेंट्स एक्झाम ओरिएंटेड आहेत. यातला प्रत्येक कंटेंट परीक्षेमध्ये 2 किंवा 4 मार्कांसाठी विचारला जातो. त्यामुळे व्हिडिओमध्ये सांगितलेला कंटेंट विषयी if you are having any query, any problem about any content from this video, then ask that in comment मध्ये लिहून पाठवा. त्याचा आन्सर तुम्हाला कमेंट मध्ये देण्यात येईल. and thank you very much for watching this video. आणि व्हिडिओ पाहिल्यानंतर जर तुम्हाला हा व्हिडिओ आवडला तर त्याला लाईक आणि शेअर करायला विसरू नका. थँक यू व्हेरी मच.